Good morning. I am R. Krishnakumar from Mechanical and Mechatronics Department. Today we discuss about theory of machine, second year BE Mechanical and Mechatronics Engineering, fourth semester, Unit 1 Mechanism and Kinematics. The topic is mobility. Mobility in mechanism and kinematics. Mobility is one of the most important concepts in the study of mechanism and kinematics. It refers to the number of independent movements or motion that are mechanical process. In other words, mobility indicate how many independent joints input parameters are required to completely define the position of every link in mechanism at any instant. The concept of mobility helps engineers understand whether a mechanism will move a intended remain stationary or become over constrained. Mobility is also known as degree of freedom of a mechanism. The study of mobility is essential in the design and analysis of machines such as engines, robots, manufacturing equipments, automotive system, aircrafts, control system, and various mechanical devices. A mechanism is formed by connecting rigid bodies called links through joints or kinematic pairs. These link and join constrain the relative motion between different spots of the mechanism. The mobility of a mechanism depends on the number of links, the number and types of joints, and the constraint imposed by these joints. The primary objective of mobility analysis is to determine the number of independent motion available in a mechanical system. In kinematics, a degree of freedom is defined as the minimum number of independent coordinates required to specify the position and orientation of the body in space. A free rigid body moving in a three-dimensional space possesses a 6 degree of freedom. Three translation motion along the x, y, z axis and the three rotational motion about the axis. In two-dimensional planar motion, a rigid body has 3 degree of freedom. In kinematics, a degree of freedom is defined as the minimum number of independent coordinates required to specify the position and orientation of the body in space. A free body moving in three-dimensional space possesses 6 degree of freedom. Three translation motion along the x, y, and z axis and three rotational motion about this axis in two-dimensional planar mechanism. A rigid body has 3 degree of freedom. Two translation motion along the x and y direction and one rotational motion about an axis perpendicular to the plane. When joints are introduced between links, these 3 degree of freedom are reduced because the joints impose restriction on relative motion. A simple example of a mobility analysis is the four-bar linkage, which is one of the most common mechanisms used in engineering application. A four-bar linkage consists of a four-link connecting by four revolute joints. Using the mobility equation, the number of links is 4 and the number of lower pair is 4. Substituting this value into mobility equation gives a mobility of 1. This means that one input motion is required to control the entire mechanism. As one link rotates, the position of all other are uniquely determined. These characteristics makes the four-bar linkage useful in machines, engines, pumps, and robotic system. Another example is the slider crank mechanism used in internal combustion engine. Mobility analysis is a crucial during the design stage of mechanical system because it helps identify potential problem before fabrication. A mechanism with insufficient mobility may fail to perform the desired task, while excessive mobility can result in uncontrolled motion and stability. Engineers use mobility calculation to ensure the mechanism achieve the required functionality while maintaining structural integrity. In robotic system, mobility plays a significant role in determining the flexibility and the capability of the robotic manipulators. Industrial robots often have 6 degrees of freedom, enabling them to position and orient tools in three-dimensional spaces. Thank you.